Welcome everyone to the first episode of the related rate series. So the question we're given is the volume of a sphere is 36 pi centimeters cubed and its rate of decrease is negative 6 pi centimeters cubed. The magnitude of the rate of decrease in centimeters squared per second of the surface area of the greatest cube inscribed within the sphere is. So we're asked to find that and they've already given us the unit. So we just need to find a number. So let's try to make some sense of this. We're given the volume of a sphere, right? And we're given a number for that. But we also know that the volume of a sphere, so the formula for that is just V equals 4 thirds pi r cubed. And since this is also equal to 36 pi, and we just ignore the units for now. Since these two are equal, we can actually just solve for r cubed. And that would tell us, so to find r cubed, you can just leave that there, cancel out the pi's, multiply by 3 and divide by 4, which would give you r equals 3. So r equals 3 centimeters. So that's some useful information. Now let's actually draw the sphere that we're going to be working with, and drawing the cube is actually something even more interesting. So this is a sphere. We know that the radius is 3. Let's draw the cube now. So the cube is going to look something like this, and it's not perfect, of course, but this is just like a rough sketch. Because remember, it's 3D, so it's going to look a bit different than you might expect. So let's say it's like this. Of course, it doesn't look perfect, but okay. So basically, you could. That's not drawn too well, but this this is going to be the space diagonal of the cube, right? And this is also going to be a diameter of the circle. That's how you maximize uh, the cube size, and therefore its surface area. So let's say this is the middle point, right? And now that this is the middle point, this becomes r, right? The radius of the sphere, and this also becomes r. But what do we know that 2r is? 2r is equal to the space diagonal of the cube. Let's say it's got a side length of s, and the space diagonal is basically the square root of s squared plus s squared plus s squared, which is just equal to s root 3. So we've got this connection now. So 2r equals s root 3. What do we want to find? And another thing to note actually is this, the rate of decrease, which we will use very shortly. Until then, what do we need to find? We need to find the rate of decrease of the surface area of the greatest cube. So this is the greatest cube where you've got 2r equals s root 3. And we want to find its surface area. So the surface area, what is that going to be? So the formula for surface area, I'm just going to call that A. That's just going to be 6s squared. Okay, so this tells us if we solve for s, we get s equals 2r over root 3. So we can just plug that in over here. So 6s squared equals, so 6 times this squared. So that's going to give us 6 times 4r squared over 3. And what is that equal to? You can cancel this out and you get 8r squared. So if we now try to take the derivative of this, so the same exact thing, dA dt, what do we get? Well, we get 16r, and then we get dr dt. Now we've got 16r. We know what r is as well, actually. R is just this thing right over here, 3 centimeters. So we just need to find dr dt. How are we going to do that? Well, let's look back over here. We're given that the rate of decrease of the volume is negative 6 pi centimeters cubed per second. So let's make another equation here. The derivative of the volume with respect to time. So dv dt. And what is this going to be? This is going to be 4 pi r squared dr, and I think you might see it now, dr dt. And we know what r is, right? We also know what dv dt is actually. I should write that. I'll just write that here. Negative 6 pi. Okay. So what is this? Now we know that r is, so let's just cancel out the pi's first of all. Let me use a different color. We've used quite a bit of white already. So let's use red here. So you can cancel out the pi's. And now we can go back. So 4 times r squared, right? R squared is 3 squared, which is 9. So you divide it by 36, you get dr dt is equal to negative 6 over what, over 36, right? So that will be negative 6 over 36, so negative 1/6. Okay, perfect. Now let's plop that in here, right? Negative 1/6 is dr dt. And so this is going to become 16 times 3 times negative 1/6. Now let's solve this. What does this give us? This will just give us negative 8. And remember, we've still got units, centimeters squared per second. Luckily for us, we don't care about the units. We're already given that here. And they're asking for the magnitude of the rate of decrease. So the magnitude of that is just going to be 8 because it's negative 8. So the absolute value is 8. So I'll see you in the next video.